And no, so I would just briefly present that what are my experiences till date and what are the opportunities if you are selecting this cement industry as your career. So I will say that right now I'm working already. They have introduced, I mean, the faculty has introduced about my current position that I'm working with Ultratech Cement as a corporate quality, looking after this research and sustainability. Sustainability is a big word. Of course, we have a lot I mean, lot of thing to do here. So sustainability typically means like now everyone is looking for how to reduce the carbon dioxide emissions because you know that producing a cement and particularly for making the cement, you need that your clinker. So clinker is the basic raw material for making that cement. And during the manufacturing of clinker, you know that it is a long process. You need limestone. I have some presentation. I will try to take you all through that presentation that how this clinker is produced, which is finally used in the cement. So during the production of that clinker, normally for producing 1 ton of clinker, you I think around 850 kg of carbon dioxide is released into the atmosphere, which is polluting. So many scientists are doing the work. Of course, we have got achievements also. And finally, we in cement, we have come to around 300 kg of carbon dioxide for producing 1 ton of cement. Through the initiatives, how to reduce the clinker factor, I mean, through various steps, by the use of the alternate raw material, alternate fuels. So all these things have really upgraded, but there are many more things which is required to by the research activity which are required which can further bring down the CO2 emissions and we can provide us a green atmosphere to the society. So if I'm talking about that like cement industries, so cement industries, you know that infrastructure activities, lot of infrastructure is going, and India still is a developing country, and where we have to move from these transformations from this developing to developed state. So if we are in the developing, we are recognized as developing country, it means that lot of infrastructure has to be developed to convert ourselves from this developing path to the developed path, right? So, infrastructure activity, you know that cement is the basic raw material in that one. And therefore, if I'm looking about like you have a good, if somebody is selecting cement as career opportunity, there are huge opportunities for you. As per the research is concerned, already I told you that lot of things you can do in sustainability, cement sustainability, research activity. Now you know that to maintain that sustainability, the things are like carbon capture and utilization is coming, how you can, what are the CO2 being emitted when producing that clinker, how you can arrest that carbon dioxide, how can you can capture that carbon dioxide and again use it for as a raw material for the cement industries. You know that the basic raw material used in the cement industry is limestone, and limestone is the basic raw material for the cement industries. And if uh, anything is lacking in that limestone, because you have many components in that one like silica, alumina, iron, these are some major oxides which are produced in this limestone. If anything is absent in that limestone, which is uh, deficit, so you would like to compensate from the other raw materials to satisfy the requirement, finally, whatever it is going to be produced for your cement. So based on that, many we have to design some Rawmix design. We have designed the Rawmix design. If limestone itself have all the properties, then only one component is there. Otherwise, if all the raw materials are being used, if silica is deficit, you have to add a source of silica with that limestone. If alumina is deficit, then you have to add bauxite. If iron is there, then you have to like add some iron ore to satisfy the requirement of the cement what you are finally looking at. So I will, it is just a brief one that I would like to state. I will show it through the presentation also. So a lot of homework we have to do. If somebody is asking you that no, you have to go for a new cement plant, then as a layman, what you will do? Like you are the owner. Somebody in the last lecture was providing that giving the lecture of entrepreneurship, right? That if you want to enter into the business of a cement industry, what are the basic requirements? What are the infrastructure activity, right? and what are the job opportunities for your nearby area, what are the research activity being associated in that one. So everything you have to take into consideration, the proper feasibility study, you have to do it, right? So first of all, wherever you want to make the cement industry, you have to look for the mines, like limestone mines should be there. And of course, whatever the limestone which is there, you have to check it, and you have to count the number of years. That suppose your production capacity, based on the production capacity, you have to order for the plant also, and also you have to look that if your limestone satisfy the requirement of the cement which is finally going to be produced, then only it is the best option. So the basic requirement is you should have a better quality limestone mines. The second thing is, suppose you have a better quality limestone, but something, some ingredients are missing in that one. That is some chemical composition like silica is missing. Then you have to see that nearby source for that silica, that what that sandstone is there, what would be the cost of the sandstone. It should be highly economical, feasible, like no that instead of going directly for the cement production, it should be feasible, because you are looking for a entrepreneurship no, into the cement industries, right? Then finally, that opportunities, if for the students nearby, like no, you have to give the job opportunities to them. You have to make them research. You have to just think for the research activities, like what are the research activities which you can give to your nearby areas. Like no, because lot of employment generation, you know that you might be many of the students would be near to that no location of visibility, like vicinity of the cement industry. So definitely you might be knowing that lot of job opportunities are there, whether from this electrical, if you're many departments are involved in that one. So it is a huge industry, huge investment. So a lot of job opportunities are there, right? But the final cement, whatever you are getting it, like which is going to be used and satisfy the customer requirement as per their, like if finally it is being used in the concrete, right? So all you are from the concrete, so you know that no, in concrete you should perform better, because if the cement is not performing better in the concrete, there is no relevance, right? So if in concrete stage, then you are adding some sand, you are adding different type of sand and aggregates, right? So this should also react with your cement, right? It should not positively react, it should not be negatively react, like alkali silica reactions and all those things. So you have to check it at the different, because from apart from the cement, you are adding other raw materials for making the concrete. So concretes, I think I will not take into so much details. So because you are the first year student, I understand. But the concrete are also various types, like no, M from starting from like M20, M25, M30. If we are going for some metro projects like M60 and 65. So for that requirement, also different type of cements are there, because cements are like OPC, PPC, PSC, and CC. And apart from that, some special grades like 53S are also there, right? So OPC, what we say, it is like ordinary Portland cement. Ordinary Portland cement meant you are adding just your clinker with the gypsum, right? Gypsum is also a material which is a set-in time regulator. It is also a mineral, but right now it is also coming from the fertilizer industry as name as chemical gypsum. So it is a waste product from them. So, and PPC is like Pozzolana Portland cement, and which we normally knows. Yeah, please. Yeah, please. Yeah, yeah. I will just share it after this. I will share it. Just yeah, I will share it first. Let me introduce so that no, it will not bounce to them, right? So let me introduce. Yeah, yeah. So it is like that. No, that PPC is there, and the PPC is Pozzolana Portland cement. So you know that Pozzolana, I think everyone should be aware about that one. So Pozzolana is normally that pulverized fuel as, which is the waste product from the power plant, and PSC is Portland slag cement. So it is the waste product for the steel industry, from the steel industries, right? So cement industries, in a nutshell, you can say that cement industry is the only industry which is acting like Lord Shiva. In one term, I will just say that no, Lord Shiva, because these are all that no. hazardous category or like waste products, many, because now I can say hazardous also because AFR is also used, which is the waste mode product from various industries, right? So all these waste are used in the cement industries as a raw material finally, and finally the cement is being produced without any compromise, maintaining the same quality. So it is why I have compared this as a Lord Shiva, because Lord Shiva, you know that when the poison was there, he has, taken that poison, right? So cement industry is also that no, whatever the waste uh, products being given or like produced from that various industries, whether it is pharmaceutical industries, whether it is power plant, whether it is steel plant, all the things are used as a raw material. They are the waste are converted as a raw material for the cement industries and finally used in their product. So it is compared into that one side. So from this, now what I will do, I will just try to share you. I have few slides, and if you have any doubts, you can just connect me after the presentation. So it is like Rawmix design. I will talk about the Rawmix design. That what is the Rawmix design and how it is useful, like no in making your clinker, which is the basic raw material. And then we will talk about that sustainability, carbon capture, and how carbon capture is being used. And again, it is converted into limestone, right? So just I will try to share the presentation on the Romix design, what I have. Uh, I hope it is visible. Yeah. So I will just share that cement chemistry starting from the Romix design, where I explained you that what are the things which the cement for making the cement and like the basic raw material limestone used for making the clinker, how it is used. So the objective is why do we need Romix design and when do we need Romix design and what are the prerequisites for the Romix design. Uh, so already explained that no, for calculating the mixed proportions of the various raw materials, that is limestone, and if limestone is having some deficit which cement should have, then we are adding some additives and have the proper proportioning, right? Proper proportioning system should be there so that you ensure that there is proper mixing of that materials to avoid any high standard deviation or deviation in the quality. So why I am talking about the research, like why people are doing so much research in the cement industry, that is like no, we are concerned about the environment, about the reserves, because now you know that India has has increased the capacity in the cement industry, and now many cement industries still there are like opportunities to further enhance the capacity of the cement. So looking into this one, like we have to very intelligently, or you can say that in a very proper manner, we have to utilize the natural resources. We cannot waste that raw material. Whatever the raw materials we have to use in a proper way so that no there will be no further no depletion of the natural resources, and finally after 30 years we will not have any limestone to produce the cement, right? So we have to use in a very proper way, proper manner, we have to use that one. So if I'm comparing the today's cement industries the activities and and what it was like before, so there is a huge difference, right? First of all, before the cement industries were on the model of the wet process. Now it has, and the volumes were very less, and the capacity of the kiln was very less. Now the cement plant has increased the capacity and moved from the wet process to dry process. So dry process, dry process is something like no, whatever the raw material using, you have raw material, you have, raw mill, and after that limestone is there. You are making the limestone pile. After that, raw mill grinding, and finally your clinker is produced with many digitalization and instrument techniques, testing to ensure that whatever the qualities which you have predetermined, it is going to match that one, right? So bigger model plants right now, because if you are comparing with the last time or past. So that time our cement industries never bothered about how to save the fuel energy, how to properly use the mineral consumption. So that time there was no so much challenge. The big industries were very few, and there were no competition also. You know that now a lot of competitions are there in among the cement industry. Some are giving good product quality. So everybody is challenged that no, they should not be have the minimum quantity. So of course we have some regulatory bodies to control the quality, whatever the cement industries are producing. But whatever the quality the other cement plants are producing, it is much more than that one, because you have to beat it. You have to be the standard. You have to be like at the upper level, right? So BIS has given the minimum requirement, but everyone is crossing almost 30%. I'm above that whatever the requirements we have, just to make in the competition in the market very competitive, right? So bigger size of modern plants have like a lot of fuel energy. Now we think about how to save the fuel energy. So here to save the fuel, I mean energy, and to use the alternate fuel, we are using AFR, alternate fuels, like the waste products I told you from many of the industries, right? And the mineral, that mineral also, like suppose the limestone is used, everyone is using the high quality limestone, then there will be depletion, and after some time there will be no good quality limestone. So alternate source of limestone can be also used. In my future slides I will just show you that, no, I mean in my next slides I will show you that how, what are the kinds of other sources of the limestone. And higher volume of handling, complicated and heterogeneous limestone deposits. So if why the modern systems needs this type of upgradations is that, no, before nobody bothered about that your limestone deposit is heterogeneous or what. They were just taking the good quality of limestone and depleting the other one. So they were not using the proper utilization of the limestone, right? Now the things are like, no, we used everything, like, no, if the rejected limestone also is there, then we are using in a proper way so that we can have that conservation of the natural resources. And also, as I told you, the customer perspective has changed. Now they have become educated. Everybody is aware about the quality. Before that, nobody was aware. For them, the cement was only the cement, right? If it has a, like, that binding effect, so they were saying that it is a cement. So nobody bothered about the quality, what is the quality. And but now the customers are very educated, so they are demanding that this is the thing which we require, whether it is setting time, whether it is quality. The Rawmix, similarly, the Rawmix, as you know, that time a few plants were there, so the deposits were very good, and no, there were hardly any situation that apart from the limestone, you have to use any of the raw materials in the Rawmix design, right? So Rawmix design is basically the design that you are making it to make your clinker and finally for your cement, right? So if your raw mix design is okay, then everything is okay because your clinker quality will be okay, and finally your cement quality will be okay. So to ensure a proper cement quality, you should have a better, like, raw mix design. And to have a better raw mix design, you should have a better, I mean, the raw material which is used in the raw mix design. So as I told you that before, like nobody bothered only limestone, but they were just selecting the good quality of limestone and they were using it and finally making it the clinker, right? But there were the depletion. But now the thing is that we have modern systems like CBA, that is cross belt analyzer, which is selecting that quality of the limestone without any deviations, so that no, you did not have to do a lot of homeworks and the quality deviation at the clinker stage. So if let me explain, because I'm always saying that clinker, so you people would be confusing that what exactly is the clinker. Clinker is basically the raw material for making the cement, and whatever the I told you that raw mix design you have made after that grinding, different preheaters are there, like no different heating capacities are there of the different cyclones in the cement industries, like 6 stage, 7 stage, and the material is very slowly burned from different cyclone, that you can take it like from starting from like 150, and different types of reactions are being happening, right? So the reactions is happening in the way, like you can say starting from 150 degrees Celsius, the moisture of the raw material, whatever the raw mix you have grinded, it is finally evaporated. And after that, entering the different system, the temperature is 300 degrees Celsius. Finally, in a different cyclone, the same material is at 600, where there is dehydration, or like you can say that no calcination of magnesium carbonate. And finally, because from the calcium, you know that limestone is basically the calcium carbonate, and you have to, for making the clinker, the basic important parameter is your lime, right? So finally, at the temperature of 800 to 850 degrees Celsius, your limestone, that is calcium carbonate, is dissociated into lime and carbon dioxide. So this is the stage where your carbon dioxide is being released at 850 degrees Celsius, right? At the pre-calciner zone. So this carbon dioxide is going to the atmosphere and polluting it. So we have to work with your guidance, with your experiences, because you are the new students, definitely new students have a new type of technology. We are with the old technology, old mind setup. So here the help is required by the different research activity, how to capture that carbon dioxide. Of course, research activity is going out globally, how to carbon dioxide, the calcinated that carbon dioxide, and again use this with that waste lime and make it a limestone, so that the depletion of the limestone cannot be used, and the same that raw material which you have made from arresting that carbon dioxide and the lime from the other raw materials and use as a limestone for making the other clinker, right? So these things, this technology you have to think of, because every scientist there, that lot of funds is being given for this, all these research activities, and many research institutions, good research institutions are working on this platform. So here it is an opportunity for you. And also, like at the concrete stage, how you can use this carbon dioxide, right, as a filler, so that the durability can be increased. So this is the exercise everyone is doing, and there your research, whatever your learnings are there, you have to put forward. If you are selecting as a career path, so I am saying that no, it is a huge career opportunity, and you will learn a lot of things, and you will contribute to the society in a better way. So this I know, after that 850 degrees Celsius, then it enters into the kiln, right? Kiln is like not that material which is being 850. You know that it has lime, and of course the other raw materials are also there, like alumina, iron, and MgO. So it all forms the phases like C3s, clinker phases, C3s, C2s, C3, and C4f, right? So these are like, no, I'm saying that raw material, that C3s, right, and C2s is there. So all are governed by three governing factors, that is from the clinker to the finished product, that is LSF, SM, and AM. LSF is the lime saturation factor, and it has a formula I will show you. And silica modulus is there, and AM is the alumina modulus. So all these governing factors are there. And finally, in the inside the kiln, your clinker is formed at a temperature of 1400 degrees Celsius, right? For which the fuel is required. And the fuel is required both at the calciner stage, where there is a calcination of your calcium carbon dioxide to calcium carbonate to calcium oxide and carbon dioxide. And similarly, your clinker phases, what I am talking about, C3S, C2A, which is basically we should be good in the clinker at the kiln, that is at 1400 degrees Celsius. So finally, when your clinker is produced, then you are grinding at the cement stage. And if you are making the OPC, right, then what will happen if you are grinding at the OPC stage? So only your clinker will be grinded with the gypsum, right? That is ordinary Portland cement. And if you want to make PPC, then the power plant fly ash is added with this clinker and gypsum, and your PPC is produced. And if your slag is there, then you have with the clinker, your gypsum, slag, and your this clinker is added, and your slag is produced, right? So this is the Rawmix design. What I am talking to you, how it is designed. You can see that we are selecting, suppose limestone, right? Clay, if any deficit is there, if for the alumina or silica. And if your limestone itself have all the properties, so nothing is required, no clay, no sand, no iron, or nothing is required, right? But if there is some deficit of alumina iron, then other components are used. So what after that, what you will do, you will just write that what is the chemical composition, that silica, what is the percentage of silica, what is the percentage of alumina, that you will do through the different instrument technique, like XRF is there, which is based on the technology of X-ray fluorescent, and like XRD is there, which is like no diffraction technology is there, right? So this is just a mineral composition based on the this XRF study, right? And also finally, what I told you about cost is also important, as you know that the cement cost, if you are comparing with the other products as per the inflation is concerned, cement like no cost is still at the lower side, right? So finally, for the cement industries also, we cannot stop the infrastructure activity. So the cost is also a very important part that we have to look upon, right? And also the moisture content, which is given as like H2O, which is also very important, because why, if your component has high moisture, then you need more fuel to absorb that heat or evaporate that heat, right? So the your fuel consumption will be very high. So if your fuel consumption will be very high, so one way your cost will be also very high, and the other way that no that your energy requirement will be also very high, right? So this is the Excel sheet what I have shown. So this is calculated based on this one, and this is just based on the Rawmix design. So I will not go into the details. This is the limestone quality, and what I was talking about this like alumina ratio and this one. So limestone is there. So basic component is silica, alumina, iron, lime. In limestone we see only lime. That MgO is the also requirement loss, and sulfate is also sulfur is also requirement, and with that alkali like K2, Na2. I think you are the chemistry student, so definitely you might be knowing that what is the silica, and like so with the XRF we are converted into the form of that oxides, right? And the main important is your fuel. Like fuel is also very important, and as you know that the fuel is used to burn that raw material, because finally your clinker is produced at a temperature of 1400 degrees Celsius, or in some plant where you are like no there is burnability is very hard, where you have some quartz content, because I told you know that if you are going into details, many things are there. If everything is given to you, but then also the burnability is not there, then you have to look for other research instrument technique why it is happening so, right? And finally you have to come with the conclusion. If you have to see that no which raw materials has the burnability less, right? Which is like easy burn, which is very hard burn, no use, because high fuel will be consumed in that one, right? So finally, the coal is being used in that one. So coal also, you know that coal is used like almost like 11 to 12%, whatever the clinker is produced, that no 11 to 12% of the fuel is being consumed to burn that raw materials, right? And you know that pet coke after when the coal was there, and huge consumption of coal was there, so everybody started crying that no, after few years there will be no scarcity of this coal, so we have to look for some alternate options, right? So then this pet coke came into consideration, because pet coke was the waste product from the oil and petroleum industries, right? So it contains a good amount of calorific value, because CV is very important. You can see that whatever I have highlighted, it is written at net CV. For whatever the fuel you are selecting, it is based on your net CV, that is net calorific value, right? So this plays a very important role in deciding no that the fuel whatever mix what you are going to give it to your burnability of the raw materials, right? And finally, the important parameter is fuel, that fuel consumptions, right? So this is the waste product. As I told you that no waste product of in the fuel also we are using as the waste product, that is your pet coke, right? This is the proportions of your I'm just clinker capacity. Clinker C3S is given like it is always in the range of around 58 to 62, and if it is on the lower side, then your clinker has very less strength, and finally your cement will be have the less strength. Clinker LSF finally for making your clinker C3S in the range of 58 to 62, you need the LSF between 96 to 98, and similarly the silica ratio that is 2.4 to 2.6, it is given the range, And these all important parameters like your LSF, silica ratio, and A upon F, that is alumina modulus, this all ranges is used to have your clinker with your no C3S percentage 58 to 62. So here you can see one term is written in the free lime form like 1.5. Free lime is the lime which is unreacted lime, that is a wasted lime. So you have to think that no, the if it is less free lime, then your clinker quality will be good. So these are some of the formulas being used when you are going for the C3S, because this is very important. So I will not go into the details. This is C3S, C2S, C3S, C4AF, and these are some formulas used in that one. And you might be aware that if I'm talking about the waste product, then the red mud is also the waste product from this alumina industries, right? So as the slag, as your like fly ash, as your AFR, that is alternate fuel, like the waste product. So similarly, the red mud, which is the waste product of the steel plants, also used in the cement industries to maintain that balance of alkali sulfur, which can really no, due to the change in the fuel, which can have very harmful, no, I mean, effects. So this is, I will not go, it is like clinker capacity, how we are making it, and based on that, how we are designing the raw mix, and finally coming to know improve the quality. This is the raw material chemistry. So as you know that the four phases which are used for making the calculation of your C3S, that is your line, silica oxide, alumina, and iron. So it is for applicable both for your raw materials and also for your like clinker also. So these are some sources, as I told you that what can be the sources, alternate sources if your limestone has the deficit of any of the raw material. So if your limestone has the deficit of your like silica, then the sources which are being used is clay, shale, and the sandstone. And if your Rawmix has the deficit of alumina, so you know that clay has to be used, shale has to be used, and bauxite. But bauxite, of course, bauxite is a mineral, and this also has can be depleted because it is a source of alumina only. So now we are using a red mud, which is the waste product for the this from the steel plants, alumina plants, sorry. And similarly, the iron, and for iron, we are using iron ore, iron rich clay if it is deficient in the limestone. And if MgO is there, then dolomite is used. For lime, we are using majorly limestone, everybody is aware. And for sulfur, of course, sulfur deficit, then pyritic sulfur is there in the limestone, or you can use it from that fuel. Similarly, the Na2 is there, for alkali, clay is there, and for chloride also clay is there. So what this is the ranges in the Rawmix design, what you will get in the clinker. If in the Rawmix design you have to fix the silica, I have given the ranges for all the cement industries globally. That is 13 to silica. So your clinker in clinker, that silica will be 20 to 24. If your alumina in the Rawmix is 2 to 4, in the clinker it will 3 to 6. And if we iron is there, then 1 to 5, and the lime is there 41 to 45. So in clinker, it will be giving 62 to 68. 62 to 68 is finally your that factor. I mean, whatever you are converting it, right? So don't say that everybody should be confused that why in the raw mix it is 41, how in the clinker it has been increased, right? So it is by that ash absorption and also like the clinker factor. You know that suppose 1.5 ton of raw mix is you are giving inside the kiln, then only 1 ton of clinker will be produced, right? So that other like no zero point 0.5 will be the loss. What I have shown the calculation loss and other losses will be there. So the factor is like no calculated. That is from the raw mix to the clinker factor. That is so it will be 1.5, or in some plant it will be 1.56. So it depends upon the loss, right? Based on that, like no ash absorption, and if you are comparing with the clinker factor, so you can say that the 41 into 1.5, so you will get that near to about this value 62, whatever I'm saying about, right? So this is the formula for the silica modulus. And now the thing is like, what will happen no if any of these factors are no up and down? So it will deteriorate your clinker quality. So that will be governed inside the clinker. So the process should control, or the process should be so much effective that whatever you are producing, it should be in the better way, right? So these are the typical ranges. If any silica modeler, suppose you have selected in the range of 2.4, but if it is more or less, then what will happen, right? So it governs the solid liquid. It indicates your Rawmix burnability. If it is high, your Rawmix will very hard burn. So everything you have to look into the considerations, right? Similarly, so what will happen? So I told you that if it is high, the burnability will be difficult and high energy consumptions, poor clinker quality. So you have to put into that range, right? Similarly, it is for the alumina modulus or A upon iron range, right? It contains the flux effect because inside the kiln, if the raw material it is burned, right? So liquid is very important in that one to make the nodules. I think you might many people would have seen that clinker how it looks, and if nobody has seen, and then I will request the faculty to at least make them to visit the cement industry so that they can understand the process and also understand that how the clinker is formed and how it looks like. So to make that clinker like in the nodule formation, lot of activities has to be done. Then because I am unable to show all these activities through the presentation, but it is a very tough and all what a tough task to make that clinker, and long process, long energy, lot of manpower is being involved in that one. So when you are visiting the plant, then you will be aware that how much effect is being produced, because finally when you are going to make your house, you are just buying 50 kg of cement or whatever the consumption it is there, and just to have that binding effect you are producing. But for making that cement, then how much care we have taken and how much effort we are putting. So this will happen. What will happen if your LSF is high? So what will happen if your AM is high? Similarly, this is the relation between the temperature. Finally, in the clinker, whatever it is produced, it is C3S, C2S, C3, and C4F. C3S is your tricalcium silicate, which is formed by three molecules of lime and one molecule of silica. Similarly, for this C2S, also two molecules of lime inside the clinker. When it reacts with the silica, it forms C2S. Then C3A is there. Then three molecules of lime react with the alumina in the raw mix. It forms C3A. C3A is performing the acting of your gypsum, which is a setting time regulator, right? Because setting time is something like no, you are giving the time to mold whatever the cement being used. If your setting time is less, you will not get the lime. So based on the requirement, we have to decide the setting time also. This is the LSF formula, which is applicable based on certain scientific notations. We have identified that why this factor should be taken and what should be in the range. Similarly, it is for you. You can say that no iron is there. What should be in the iron range, and CO2, whatever you are looking after, it is your calcinations, right? And this line saturation factor LSF, what I was talking about, it is the transformation of your C2S into C3S, right? And similarly, if we are talking about the silica modulus, it controls the Rawmix burnability, and this is the range. And from where it is coming, you can see in the upper side, it is written silica 14.45%, right? And A upon F, that is the alumina upon iron ratio, it controls the viscosity, and also it is used for the liquid formation for making the nodulization of your clinker, which can finally use in your cement grinding to make your cement. This is the formula of the liquid, because if liquid is less or more, then also it can be a problem to make your clinker. It will deteriorate your clinker quality. It will impact your clinker quality. So it is like what will happen if your liquid is low, right? And how it is going to impact the grindability and also your like cement strength, right? This is your tendency. Alkali. So alkali is something as a concrete students, concrete engineers, like, and you know that alkali is a very important parameter because you will be adding with the cement different aggregates, and you will be adding some admixtures to control that no setting time, and for the workability, whatever in cement plant we are saying that the normal consistency or the water demand. So this is very important. So alkali is one of the factor which really impact all those parameters in the concrete, right? Because of the alkali, silica reactions, alkali silica from that aggregates, and alkali, whether it is coming from the cement or whether it is coming from the aggregate, whatever you are using, right? So you have to ensure that whatever the alkalis, whether it is from the cement or aggregates, it matches so that no, you can have a better concrete quality. So it modifies the workability and it promotes the reaction of the alkali aggregate interaction with the concrete admixture. So this is the formula Na2 equivalent, which is given below. So it is produced during the volatilization inside the kiln. If it is coming out of the cement and if it is coming from your like admixture or aggregates, then you have to do the proper analysis. So this is what I was talking about C3S, C2S, C3S, C4A. Now the second, what I was talking about the research technology, right? You can see that raw meal has the silica S, and it is written that iron in the form notation is F, alumina is E, calcium carbonate is C. So after that, you can see that clinkering temperature, right? Clinkering temperature is the temperature in which your clinker is formed. So it is converted into C3S, C2S, C3, and C4F. That is in the clinker, right? As I already told you that no tricalcium silicate, dicalcium silicate, tetra calcium aluminate, and tetra calcium aluminoferrite, right? So this is the formula, and this is the finally what we see, in the clinker, and we know that what are the ideal parameters for that one, right? So this has to be understand in a better way. What I have written here in C3S elite and belite, because it has also different forms. If your C3S, if you are getting a better C3S also, C2S also, but you are not getting a better strength of the clinker, then it has a different polymorphs. Like no alpha, I mean 7 types of C3S is there and 5 types of C2S is there. So elite is the form because many type of impurities are there, and belite is also like the form. So belite, like no, I will not go into details. If you are like a research only for this clinker, then you might be understanding these things. This is the microscope, like if your clinker is produced and then also you are not getting like your clinker for the better reactivity, then through the microscope study you will understand that how exactly is your clinker looking into the microscope. So now you can understand that what are the techniques being used to control the burnability and also to see whether your clinker, what it is formed, it is in a better way or not. So you can see that under the microscope, like how your C3S looks like. You can see 20 micrometer is written in the C3 in the like your right side, and similarly how your C2S, like blue color is your like C2S, and similarly C3 like whitish color is your C3, and C4 is C4F is a liquid that is like dirty white, you can say that. So this is the role of your clinker phases like C3S, what I am talking about elite, what exactly it controls the clinker, right? So 48 to 60% and the ring problems, and C2S it controls lower. C3S always give, if you are like concrete engineers, then you should know that what is the role of C3S and C2S. C3S like is always for the early strength. If you want a good early strength, your C3S count should be more, right? And if you want like for the durability, and if you want that later day strength, then the C2S should be high. So finally, like no, if you are going with this high belite cement, you might be aware like people started going for high belite cement. So high belite cement is like normally no, with a good amount of C2S, where you are consuming your no good quality of limestone. So this is similar like C3 and C4AF, and this is like as I told you that what are the temperatures being used for the clinker formations. So your calcium carbonate is there normally at the 850 degrees Celsius, it is being calcined, and finally at around 1400 to 1500 degrees Celsius, your C3S is produced. You can see that it is like I have shown through this like graphical presentations. From this, I think you will understand that what exactly in the Rawmix and what type of reaction is happening in making your clinker. So this is your limestone, source of, I mean, lime for in the Rawmix design for, which is the basic raw material for making your clinker. And it contains the lime 75 to 95%. Similarly, it is the silica. source. If it is deficit, it can be shale, sandstone. And if secondary sources, what I have shown, it is a waste product, right? Because normally you have to, I told you, know that cement plant is using the waste product. So secondary sources of silica is slag and fly ash. Similarly, alumina, the sources of alumina are bauxite and shale, clay, and calconic clay. And secondary sources are fly ash, laterite, and red mud. It is a waste product from other industries. This is the waste product for the iron, and the sources, main sources of iron ore is iron ore, which is normally in the form of hematite and magnetite, and shale is there. Waste product of iron is fly ash, slag, and copper slag. And for the copper industry, it is a waste product copper slag. Slag is from the steel plant, and fly ash is from the power plant. Alkalis, I told you already that what will be the impact and how it will, no, with this ASR, how it will deteriorate your concrete quality. Sulfates, of course, it is coming from gypsum, maritime regulator, and also from this limestone in the form of pyritic sulfur. If this is like, I think, like organic carbon, which is there, which is making your Rawmix hard one. This is the fluorine material, which is really increasing the burnability of your omics if fluorine is there, right? So this looks like, no, if in your limestone these patches are seen, it means it contains fluorine, and after that it is being studied, and based on that the Romix is designed. This is the like your magnesium, right? And chlorine, how it, if chlorine is there, you know that chlorine is very dangerous, and we cannot accept because for concrete also it is it efflorescence will be created, leaching effect will be there. So how if in my limestone these patches are there, how we will identify that chlorine part is there? So these are certain concentration which are found in the major sources for alkali, sulfur, and chlorine and MgO raw materials. Silica is, you know that silica is there, and silica is something which is very hard to grind and which needs high melting point. So you need a better silica source so that your melting temperature will be less. And based on that, you can have a good burnability of your omics. Similarly, it is like free silica, right? Already, I told you that free silica is there. So whatever the quad is there, if it is in the form of free silica, it is very dangerous. It is kaolinite, and I think everyone is aware about this LC3 limestone calcined cement, in which we are using the waste product for making the cement, and where the clinker is very less. So they are the kaolinitic, that is kaolinite, whatever it is written. No? It is a good source of alumina, and it helps to increase to make your cement of LC3, right? So LC3 is based totally based on this kaolinitic clay. If the kaolinitic percentage is more, that whatever it is 39, basically the requirement should be more than 45 for making the LC3 cement. So you can have a cement with without I mean very less clinker and good amount of clay. So now we are producing like cement like LC3 without no more clinker, very less clinker, right? And research are going on how to make without clinker. So now you will have a cement without clinker, so nothing has to be involved, and just with the help of raw material, increase the reactivity, and with the other alumina source, you can finally, increase the reactivity and finally have an alternate source of cement. This is what will happen if your silica source will increase, and how it will impact the burnability. Sizes are also very important. There it comes the role of the microscope. Similarly, for this limestone also, sizes are very important. So it has to be grounded in the raw mill. So for that, the residue is a very important parameter. These are the forms when you are doing through the XID, how it looks like in the cell. Quartz will be, your silica will be in the form of elite, and quartz and limestone it will form of these forms. So these are the like in XID, you will look like, it will looks like. So easier to burn, the sizes are given that less than 20 and between 20 to 20 micrometer. If then your burnability will be very important. So this is just a small general. I know that it will be very difficult to understand, uh, but this is a short snap that how the cement plants are using all these raw materials for making the cement, right? So you will be understanding, just understanding that cement is something which is coming to you, and but a long intensive process is being used for making the cement, right? So the basic is your raw material is, you should have a clinker, and the clinker all this raw material used in a proper way. So, as a concrete guy, what are my, I mean, concrete engineer, what are my expectations are with all of you, because you are from the first year, I understand from the faculty. My is like, of course, many researchers are using as a tool how to reduce or how to easy burn your Rawmix design, right? But as a researcher, I need that how you can reduce the clinker factor, what technology you can absorb, and as I mentioned, a very important parameter, calcination of your calcium carbonate, that is CO2 is being emitted. How you are going to use that CO2 and use as an alternate raw material. So these are the things that you can use it. Now the 3D printing is there, right? So how to fast accelerate the work now in the concrete technology, 3D printing is being used. So my understanding is you guys can really done a lot. You can innovate in a better way to the and contribute to the cement industry with your thoughts and ideas, like how we can improve our reactivity, or if we are talking about because finally it is going to use in your concrete industries, right? So how you are going to improve the quality of the clinker, and how all this fuel or how this limestone is being used, how you can optimize it in a better way. So this is my uh, expectations from all you young engineers, and I think definitely you will contribute, and there is a huge opportunities in the cement industries research, lot of research, like no STC is there, and good organization like VDJ is there, huge opportunities for all of us. Holcim is there, everybody is innovating in a different way. We are talking about circular economy. Circular economy is something in the cement industry which is used at how to convert the waste. Like if your cement concrete is produced, then how again used that waste into as a raw material for making the cement. So all this technology you have to adapt and give us and come us that how you can improve the circular economy in a better way, how you can know what are the visions and expectations of the people if we are talking about the cement sustainability, how you can contribute to ourselves yourselves for making and achieving this success in this way. So this is from my side. I think of course for you it will be very difficult to understand, but I hope of course you might have learned something from this presentation. And if you have any questions, then I will explain to you. And thank you to the faculty for giving me this opportunity to share my industrial experiences from the cement industry. Thank you very much. Thank you, everyone. And I wish all of you a good future, and looking forward all your these researchers to come to the cement industries and really help us to achieve more success. Thank you very much.
Uh, yeah, if you are having any clarification, please raise your questions. I hope that sir covered that first model of construction materials and technology in your first year subject about the cement. Entire story of the cement, how it is manufacturing and what are the raw materials required, and then types of the cement, and then SEMs using from that industrial byproducts, and then importance of the raw material designs, and then overview of that XRF studies related to our construction industries, right? Thank you, sir. Thank you for accepting our invitation in your busy schedule. Thank you.
Just one request, I think this student should be also, you should give the tour to the cement industries, and if you
Yes,
want any help, so
yes, sir.
that they can
Definitely.
understand, what are the process being involved, right? And when they will see the model, no, they will have the understanding that how it is being manufactured and what are the steps, no, being taken for the manufacturing of this clinker and the cement. So they will understand in a better way. Then after that, they for if we are making them to learn, no, they will learn a lot of things. It will be very easy for them to understand.
Yes, sir. Definitely, sir. We are usually visit that Arakonam plant and Alathur plant, Ultratech.
No. No, no, Arakonam plant is just your grinding unit, like
Grinding unit,
whatever the,
Alatune.
yeah. So it is just like it is like only 20%, no, it is there because the basic thing is your clinker, right?
Yes, sir.
And that grinding unit is just adding whatever the clinker is produced. So they should understand that how the clinker is being produced. That they should go through the steps from the mines, that limestone, how blasting is happening. They should know that no, we are using this technology of dynamic blasting, that no limestone. They should, if they are saying no, this is very good adventure for them, that how this limestone is now taken from the benches, how the blasting is happening, dynamite is being used there, what are the safety measures we are taking. Then they will it will look very lucrative for them and they will enjoy it.
Yes, sir. Yes, sir. Definitely, sir. Thank you, sir.
Yeah. Hello. Yeah, yeah. So thank you everyone. Thank you.